Hello, 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 and welcome. Happy Tuesday. Welcome back. Thank you for being here. It's time for math, so let's go. Honey, my multiplication shrunk the product. That is a very dated reference to an old movie that probably none of you get because you were all born in like 2010 or 9. And I'm an old person. Oh, and now I'm having an existential crisis about aging. We're not off to a good start. Oh well, we will persevere through this adversity of overwhelming anxiety relating to getting older. I'll be fine. I'll be fine. I'll be fine. So there's what we're going to need today. Something to write on, something to write with. ICANs are down yonder. They say this. Let me read them to you. I can explain how multiplying by a value less than 1 will give a smaller product. And I can multiply a fraction by a whole number. So last week when we were working with fraction multiplication, a few very intrepid mathematicians were noticing that when we multiplied by a fraction, our product ended up smaller than one of our factors. And that was really confusing, right? Because we've been conditioned and we've been so used to when we multiply by something, taking 4 times 6, for instance, our product is going to be a lot larger than 4 because we've got multiple groups of it, right? But now that we're multiplying by fractions, suddenly we're making things smaller. So I thought we'd start by taking a look at a little bit of a visualization here. So here I have 20 stars. 20 stars. I'm going to put them all in one big group. Okay, so now I've got one group of 20 stars. Or if I wanted to write it as a multiplication equation, I might say 1 group of, or 1 times 20. And how many stars are in that one group of 20? Well, 20 stars. All right, so that's where our 1 times 20 comes from. If we were to make this factor greater than 1, let's say we were to make it 4, we'd end up with 4 groups of 20. So I'd have to draw 3 more of those, which I'm not going to do because that would take a long time, and you're not here to watch me draw stars. It's not as entertaining as it might sound, and it doesn't even sound that entertaining. So we're not going to do it. So let's think about 4 groups of 20, right? So being able to say, well, 20 plus 20 plus 20 plus 20, right? That's the foundation of multiplication, right? 20, 40, 60, 80. Sure. Yeah? And our product is a lot larger than our 2 factors because we're taking multiple groups of something, right? But what if we thought about it like this? Instead of 4 times 20 was 1/4 times 20. Now this is where things get tricky, and this is where it helps to visualize it and actually draw out our multiplication here. Because if we think about 1/4 of a group of 20. So I'm going to take my group, I'm going to divide it into fourths. And I want to know what's the value or how many go in one of those fourths. So we are ending up, this is why our product ends up being less than what we originally started with. Because 1/4 is less than 1. So we have less than one group of something, right? If I have more than one of something, right, more than one pack of M&Ms, right, I'm going to have a pack of M&Ms plus some more, right? But if I take that pack of M&Ms and I break it into fractions, I can't have I can't somehow end up with magically more M&Ms, right? If I'm taking one pack of M&Ms, that's all I have, and breaking them up into equal groups, right? So if we imagine this is our pack of M&Ms with 20 M&Ms in it, maybe it's a fun size pack, we want to know what's 1/4 of that. If I break it up into 4 equal groups, what's the value of one of those groups? So let's use the deal the cards method. Let's just put some stars into equal groups until we can't anymore. 1, 2, 3, 4, 5, 6, 7, 8. Now, see, now you are watching me draw stars. I tricked you. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now we've got our 20 stars. We have put them into 4 equal groups. Just to make sure, I'm going to count and see how many are in each group. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are an equal amount in each group. If there weren't, we'd have to break up those stars into smaller pieces, right? So now we want to know what is 1/4. What is the value of 1/4 of 20? And we see that there are 5 stars in that 1/4. Okay, so the reason why our value gets smaller is because we're taking a quantity, and when we break it up into fractions, we're breaking it up into smaller groups, and we're looking inside that value. Okay, versus making, multiple groups by saying 4 times 20 is 20 plus 20 plus 20 plus 20. Okay? And now that I'm thinking about it, we can use this for mixed numbers too, couldn't we? What if we had something like this? We had 1 1/4 times 20. 1 1/4 times 20. Now, before we even get into the what's the value here, let's just do a quick check for ourselves. Is this product going to be greater than or less than 20? Is what we are multiplying 20 by, is that greater than this value here, 1 1/4? Is that value greater than or less than 1? Remember, if it's greater than 1, our product is going to be larger than our original value. If our value here is less than 1, if we're making less than 1 group, right, it's going to end up less than 20. So yeah, in this case, since 1 1/4 is greater than 1, if we put them next to each other, here's 1, here's 1 with an extra 1/4 next to it, right? 1 1/4 is essentially 5/4. So it's got more value. So our answer here is going to be, or our unknown in this equation, is going to be greater than 20. So that gives us a start. So now, let's think about it. 1 times 20, well, that's 20. We already got that here. 1/4 times 20, we already found that out here. 1/4 of 20 is 5. So 1 1/4 times 20, using our associative property, we just add them together. 20 plus 5 is 25. Right? Remembering that this, in essence, is 1 plus 1/4. So you can do 1 times 20 plus 1/4 times 20 to get 25. Let's try a couple more here on our digital whiteboard. So first question, when I show you the whiteboard, what is, or is this product, or is our unknown going to be greater than or less than our whole number? And here we've got 2/3 times 18. First step, is this going to be greater than or less than 18, our product? Is it going to be greater than or less than 18? And why Do you think that? If you think that. Okay, and then from there, think about there's a few different ways we could solve this. You could solve this one by drawing out 18 stars, putting them into 3 groups. You could do that to find thirds of 18, right? You could multiply our numerators and then simplify the improper fraction. Okay, I'm seeing lots of in the comments. I'm seeing lots of less than, and I would agree because 2/3 is less than 1. Okay, so we're making a part of one group versus repeated whole groups. So there's a few ways we can do this. Let's start by taking our 18 and we're going to divide them into thirds. So I'm going to make thirds here. And I'm going to take my 18 items, my 18 M&Ms, my 18 slices of pizza, and I'm going to deal them out until I can't anymore. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? And I've got how many tally marks in each group? Okay, I've got 6 in each group. So is my answer 6? Why not? Why isn't my answer 6? I would agree that it's not, but why not? How many thirds are we looking for here, right? 2 thirds. So we know 1/3 of 18 is 6, but we need 2/3. So in this case, we need 6 plus 6, or 12. All right, the other way to do it, multiply your numerators first. 2 times 18 is 36. Keep your denominator, and then divide by 3. 36 divided by 3. Oh, look at that. It equals 12. Just like our example up top. So our final answer in this case is going to equal 12. Let's see. And I'm seeing that in the chat. Yes, I would agree, right? Can't be just 6 because that's 1/3 times 18. So if you know what 1/3 equals, you can know what 2/3 or 3/3 or 4/3 or 5/3 or infinity thirds till the cows come home equals. Let's try one more. I think, oh, it's down here. There you are. 1 1/4 times 9. So first step, is this going to be greater than or less than 9? Is our product, let me throw an equal sign in there. Let's make it an equation with an unknown rather than an expression. There we go. 1 1/4 times 9, is that going to be greater than or less than 9? We're going to have more than one group of 9 or less than one group of 9. Right? And I'm seeing lots of mores or graters. I would agree, right? Because 1 1/4 is more than 1. It's very literally 1 plus 1/4 more. Okay? So, what we could do here, could we deal the cards out? Sure we can. Let's put it into fourths. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute. We've got 1 over here that we haven't, doesn't fit evenly in this box. So let's pause that. Because there's a way to do this, but let's pause that because it doesn't fit evenly. So let's back up here. 1 1/4 times 9. Let's remember our distributive property here. I think I said associative earlier, but I was mistaken. It's the distributive property. So let's break this down and be able to say, well, if I can take any quantity and break it up into two addends, and then multiply both of those addends to get my answer. So let me break up my 1 1/4 and say 1 times 9 plus 1/4 times 9. Okay? I think that's going to help me a little bit. So 1 times 9 is 9. Plus 1/4 times 9, which, let's multiply our numerators. 1 times 9 is 9. And keep your denominator. So 9 and 9/4. And many of you in the chat have already realized 9/4, well, that's more than 1, because 4/4 equals 1. So let's see, let's take my 9/4 here. How many groups of 4/4 can I make? How many whole ones? So 4 of these equals 1, because each of them equals 1/4. There's a group of 4/4. There's another group of 4/4. So we end up with 2 with 1/4 remaining. Now we can add that, substitute it, and add it to our 9. 9 plus 2 is 11. 11 plus 1/4 is 11 and 1/4. Okay. In the sort of that visual way, we wanted to see, okay, what is 1/4 of 9? And then we can multiply it by 5. Here's what you need to do, okay? If we're taking our 9 things and we're putting them into fourths, we have 1, 2, 3, 4, 5, 6, 7, 8, and I have 1 left over, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. How do I take this 1 and break it up into 4 groups so that I can make even groups? Yeah, I can just do 1 divided by 4, or 1/4. 1/4, 2/4, 3/4. Oops, I accidentally made a triangle there. Because I'm writing small. There we go. 1/4. So there's our last one. We divided it up into 4/4 and put one of those fourths in each group. So now we have 2 and 1/4 in each group. So 2 and 1/4 times 4, essentially, equals 9. So here, we can just say, wait a minute, if I have 1 and 1/4, I have, this is 1 here, I need 1 more fourth. So I need 1 more group of 2 and 1/4. And then I can add them all up to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 4 make 1, so of 11, and then 1/4. A little bit more confusing when we get into mixed numbers in that way, right? With these smaller values, it's a little bit easier to multiply the numerators and then rearrange your improper fraction into a mixed number, I would say. Okay. For the exit ticket, it's going to ask you a couple of things. Okay. One, it's going to ask you to determine, by looking at the expression, whether the product is going to be greater than or less than the whole number. Okay, is that fraction, are we dealing with a mixed number that's greater than 1, or are we dealing with a fraction that's less than 1? Okay, and then it's going to ask you to solve. All right, thank you for tuning in, everybody. Remember, office hours start at 11 o'clock. So I will see you there if you have questions on anything, not just what we've done today. If you have questions on any math content that we've covered in 5th grade or before that, hey, if you want to come in and practice multi-digit subtraction, we certainly can. Okay, that's fine. You want to come in and practice long division with standard algorithm, come on in, let's do it. All right. Thank you, everybody, for tuning in. I appreciate it. Good luck on the exit ticket. I will see you soon, and you know where to find me if you have any questions. Bye, y'all.